All right, welcome to The Explainer. Today we're tackling a big one, systemic lupus erythematosus, or SLE for short. It's one of those conditions where the body's own defense team, well, they start attacking the good guys. Let's get into how that happens. Okay, so what are we really talking about with lupus? At its heart, it's an autoimmune disease. And what that means is the body's defense system just gets its wires crossed. Instead of going after the bad guys like germs and viruses, it flips the script and starts attacking its own healthy stuff. It's a classic case of friendly fire. The best way to think about this, picture your immune system as like the world's most sophisticated security system. Super high tech, its whole job is to spot threats and take them out. But in lupus, that system glitches badly. It starts seeing the people who live and work in the building as the enemy. And yeah, it goes on the attack against the very place it's supposed to be protecting. So that brings us to that first word in the name, systemic. And that's a really big deal. Why? Because it means this isn't just a localized problem. Oh no, it can pop up pretty much anywhere in the body. So you know what we're gonna do? We're gonna take a little tour, a trip through the body to see exactly where this haywire security system is causing chaos. All right, let's start our tour with the stuff you can actually see, the signs that pop up when the disease really kicks into high gear. This is what's known as a flare. Okay, so when a flare hits, you might start noticing some pretty clear red flags. We're talking about things like painful sores in the mouth, maybe some hair loss that comes out of nowhere. That's what doctors call alopecia. Or even just a nagging low-grade fever you can't shake. These are basically the sirens going off on the outside, telling you that the internal security system is on high alert and something is up. But here's the thing, those outward signs, they're only half the picture. To really know what's going on, doctors have to pop the hood and look at the engine, right? See what's happening on the inside. So what are they looking for? And when they look at the blood work, they find some very specific clues. First, they see a big drop in certain white blood cells. These are called lymphocytes. Then they notice that these proteins, called complements, which are like the ammunition for the immune system, are getting all used up. And the real smoking gun? A huge spike in these specific antibodies, the anti-DNA ones. These are literally the weapons the body is creating to attack itself. Okay, let's go a little deeper on our tour. Next stop, the kidneys. And this is a big one, because the kidneys, the body's super important filtration plant, are one of the most common and most serious targets for lupus. Yeah, when lupus hits the kidneys, it's such a big deal it gets its own name, lupus nephritis. And you gotta understand, this isn't some minor side effect. It's a huge part of the disease, and it's why doctors watch kidney function like a hawk in anyone with lupus. And we're not talking about a rare thing here. Get this. About a third, 1 out of every 3 people with lupus, will have their kidneys affected. That's a massive number. It really shows you how central this is to the disease. So how do they even know it's happening? Well, often, the very first clue is something called hematuria, which is just the medical way of saying there's blood in the urine. Now, if things get worse, it can lead to something called nephrotic syndrome. That's where the kidneys get so damaged they start leaking huge amounts of protein that should be staying in the body. And look, the stakes are high. For about 10% of people with lupus nephritis, the damage is just too much. It can lead to end-stage kidney disease. And that means life becomes about dialysis or waiting for a kidney transplant. It's a really powerful reminder of just how serious this can get. Now, some things can really throw a wrench in the works when it comes to managing lupus nephritis. And one of the biggest? Pregnancy. The chances of the disease flaring up and attacking the kidneys during pregnancy, well, they're sky high. You want a number for that risk? How about this? 50%. Half, a full half of patients who've had lupus nephritis will see it come roaring back during pregnancy. That's just staggering. And it's why careful planning with a whole team of doctors is just non-negotiable. Okay, last stop on our tour, the bloodstream. And this is where things get really weird, because lupus pulls off this bizarre paradox. It's like a double-edged sword, causing 2 problems that are the complete opposite of each other at the same time. It's pretty wild. So on one side, you have the immune system going after bone marrow. This tanks your platelet count. Platelets are the little cells that help you clot, so suddenly you're at a higher risk for bleeding. But then, on the other side, the disease can cook up these rogue antibodies that do the exact opposite. They actually make your blood more likely to form dangerous clots. So you've got a bleeding risk and a clotting risk all at once. It's an incredibly tricky balancing act. All right, our tour is coming to an end, so let's kind of pull back and look at the whole map. What did we see? What does it all tell us about why they call this thing systemic? So, what are the big takeaways? Well, first, SLE is all about that security system going rogue. We saw that flares give you clues on the outside and leave fingerprints on the inside. We learned that the kidneys are a huge target with really serious risks. And finally, we saw that bizarre situation in the blood, where you can have problems with both bleeding and clotting. It really is all over the place. And that really brings us to the final and maybe most important point. If there's one thing that's true about lupus, it's that it's different for everyone. It's so unpredictable. So the real challenge, the big question we're left with, is this. How do we get so good at understanding this disease that we're not just reacting to it, but we can actually predict the path it's going to take for each person? Something to think about. Thanks for joining us for this explainer.